Good morning, afternoon, evening, everyone, whoever, wherever you are in your location. This is from our generation Gen AI AWS series, and we have a multiple presentation on this. So, you based on your interest level, you can look at a specific area of interest and watch those presentation. Then, in this particular solution, we will demonstrate how to leverage Amazon Bedrock to create a trustworthy chatbot that specializes in making wine recommendation. By combining a large language model LLM with a knowledge base, the chatbot can provide more accurate and informative response with the minimum hallucination. We just go through the architectural summary of this. This solution, we showcase the power of Amazon Bedrock, creating a specialized and trustworthy chatbot for wine recommendation. By utilizing a large language model and incorporating a knowledge base, the chatbot can provide more accurate and informative response to users' queries. This innovative approach leverages the capabilities of Amazon Bedrock to create a valuable tool for wine enthusiasts seeking personalized recommendation. Key component and their roles. Amazon Bedrock, the foundation model used to generate the chatbot responses. Knowledge base, a curated a collection of wine-related information. A streamlit application, the user interface for interacting with the chatbot. AWS Lambda, the serverless function that processes your user request and interact with LLM. API gateway handle the API request and route them to the Lambda function. The solution demonstrates how effectively utilize AWS services to create a powerful and informative chatbot that can provide valuable assistance to wine enthusiasts in selecting the perfect wine. By leveraging Amazon Bedrock and incorporating knowledge base, the chatbot can offer personalized recommendation based on user preferences, enriching the overall user experience. So let's um, sh- focus on this slide. We have leveraging the Amazon Bedrock for chatbot development. The solutions demonstrate the powerful capabilities of Amazon Bedrock in creating intelligent and informative chatbot. By combining large language model with a knowledge base, the chatbot can provide accurate and relevant response to the user queries with a RAG approach. The foundation model and knowledge base functionality within Amazon Bedrock play a crucial role in enabling this chatbot to deliver valuable insight and assistance. So here we are focusing on understanding of the approach of retrieval augmented generation RAG. So RAG, the solution is a powerful technique that involves retrieving relevant information from an Amazon Bedrock knowledge base to enhance the response generated by a large language model LLM. By incorporating the additional context, RAG enabled the LLM to provide more accurate, informative, and personalized response to user queries with minimizing the hallucination from a general purpose um, LLM. Okay, let's look at this slide how the creating the Amazon Bedrock knowledge base, the step. So highlighting the step, the process of building the knowledge base within the Amazon Bedrock framework. A database is defined to store vector embedding, which are numerical representation of the information contained in the source file. This embedded play a crucial role in enabling the LLM to effectively retrieve and process the relevant information from the knowledge base, leading to more accurate and informative response. The source can be, yeah, in this case, our source will be knowledge source will be stored in a S3 bucket. We can use any other data source as well, but S3 is the most cost effective data source bucket. So our vector data is embedded in the Amazon PostgreSQL. So look at the detail of that. The step highlights the importance of selecting a suitable database for storing the vector embedding. Amazon Aurora PostgreSQL is a highly scalable and reliable database that is well suited for this purpose. By storing the embedding in this database, the solution ensures efficient retrieval and management of the knowledge base, contributing to the overall accuracy and performance of the chatbot. So here the focus will be defining the data source. The data source, as we mentioned earlier, is in the solution is S3 bucket, which contains the source file that are ingested into the knowledge base. This step highlights the importance of defining the data source for the knowledge base. In this solution, S3 bucket serve as the data source containing the source file that are ingested into the knowledge base. The S3 bucket provides a reliable and scalable storage solution for the data, ensuring its accessibility and availability for the LLM to process and utilize. And also, it's one of the least cost data source. So this particular slide highlight the types of data source or data file we could be used for the solution. The slide highlights supported file format for the source are um, for the knowledge base are include text, HTML, PDF, CSV, SLS, and a doc. This flexibility allows for a wide range of data sources to be incorporated into the knowledge base, ensuring that the LLM has access to a diverse and comprehensive set of information so that it can be trained, and also the accuracy of the user output is based on the relevant information and in the different type of format to make the knowledge source a rich knowledge source. So let's look at how the initiating the data sync for the file source. This step highlights the crucial process of populating the Amazon Bedrock knowledge base with the relevant data. A data sync is initiated to ingest the data from the source file to the knowledge base. This ensures that the LLM has access to the necessary information to provide accurate and informative response. The data sync process involves extracting data from the source file and sorting it in a structured format within the knowledge base. So let's look at this slide where we are focusing on highlighting the embedding the vectors for the knowledge base. The data source sync iterate through each source file and call an embedding foundation model to convert the text content into a vector embedding. These embedding vector capture the semantic meaning and relationship between the word in the source file, enabling the LLM to effectively retrieve and process the relevant information. So let's look at the process of splitting the text into chunks. The step highlight the process of preparing the data for vectorization. The original text to the source file is divided into smaller chunks, making it easier to process and embed it. The chunk along with the corresponding vector data and associated metadata are then inserted as record into the vector database, creating a structured and searchable knowledge base. So let's look at how the converting your user question into vector embedding. This step highlights the initial process of user queries within the chatbot application. When a user submit a question, the application make a call to the embedding foundation model to convert the textual input to a vector representation. This vector representation allow for efficient comparison and matching with the vectors stored in the knowledge base, enabling the LLM to retrieve relevant information and generate accurate response with the minimum hallucination. So this slide we highlighting the process of performing semantic search within the application. The vectorized form of the user's question is used to query the vector database, allowing for efficient retrieval of relevant information based on semantic similarity. By comparing the vector representation of the question to the stored vector in the database, the system can identify the most relevant text chunk that are semantically related to the user query. This enabled the LLM to generate more accurate and informative response. Okay, this step we will be highlighting the importance of creating a well-crafted prompt template. The retrieved text chunk from the knowledge base provide valuable context and factual information that is used to construct the prompt template. This prompt template will guide the LLM in generating comprehensive and informative response to the user's query, ensuring that the response is relevant and aligned with the provided context. So this will give you more accurate and informative response from the user query. This step highlights LLM role in generating the final response. The prompt template is used to invoke the text foundation model, providing it with the necessary context and instruction. The LLM processes the prompt and generates a response in natural language, which include reference to the source file that were used in generating the response. This ensures that the user can trace the origin of the information provided by the chatbot. The slide kind of highlighting the potential enhancement to the solution. By adding metadata fields to the vector database, organization can refine the retrieval process and improve the accuracy of the generated response. By filtering the result of a query based on a specific metadata criteria, the LLM can focus on the most relevant information, leading to more targeted and informative recommendation. This enhancement can further enhance the capabilities of the chatbot and provide user with even more valuable insight and also accuracy with the least hallucination. So here we're going to look at enhancing the retrieval to metadata. So the by correcting the formatting metadata.json files and uploading them to the source S3 bucket and initiating another data sync, organization can effectively integrate metadata into the knowledge base. This enables the LLM to filter the result of a query based on a specific metadata criteria, providing more targeted and relevant recommendation. So any number of we can do additional sync and um, with additional data, or if any error in the data can be corrupted with the additional sync to make it the data accurate. So let's conclude this solution overall. Creating the trustworthy chatbot with Amazon Bedrock and the solution. This solution, we showcase the power of Amazon Bedrock in creating a specialized and trustworthy chatbot for wine recommendation by utilizing a large language model. And incorporating a knowledge base, the chatbot can provide more accurate and informative response to queries. This innovative approach leverages the capabilities of Amazon Bedrock to create a valuable tool for wine enthusiasts seeking personalized recommendation. So the key component and their roles. Amazon Bedrock, the foundation model used to generate chatbot responses. Knowledge base, a curated collection of wine-related information. Chatbot application, the user interface for interacting with the chatbot. So in this case, the front end is used by the Streamlit for front ending, and Amazon Lambda, the serverless function that processes user requests and interact with the LLM. API gateway handle the API request and route them to the Lambda function. Amazon Aurora PostgreSQL, the database used to store the knowledge base source file, the files containing the wine related data. The solution demonstrates how to effectively utilize AWS services to create a powerful and informative chatbot that can provide valuable assistance to wine enthusiasts in selecting the perfect wine by leveraging Amazon Bedrock and incorporating the knowledge base. The chatbot can offer personalized recommendation. The hope this will help you improve your knowledge on building Gen AI application on Amazon um, resources as well as Amazon tool set to build. Thanks for attending this session.